Hi, today we're going to solve a problem that is becoming more and more useful these days. You may run out of hand sanitizer, which is a problem with the recent coronavirus panic buying. And if you're like me, I have a household and I also have staff in an office. And I need to create some hand sanitizer, and we're finding all the store shelves empty at this point. So today we're going to go through a small tutorial about how you can create some hand sanitizer if all you have is this, which is very common rubbing alcohol. Now, a lot of rubbing alcohol, the problem with rubbing alcohol is it's only 50%. So when something is only 50%, it does not kill coronavirus. This alcohol has to be a concentration of at least 70% to kill coronavirus. So here's what rubbing alcohol is made of. It's made basically of 50% alcohol and 50% water. So our challenge here is that we have to separate out the water from the alcohol. Now there's a couple of ways to do this. One of the ways you could build yourself like a little old still like they do down south and make some moonshine. And you could do the same thing with this. You could essentially distill this, and that would remove the water. It's a little complicated, requires some fire and other things and distilling tools. So a simpler way to do it, which is a lot lower tech but also very effective, is to simply use salt. And as we see here, we have some regular salt. Now the important thing to remember about the salt is it cannot be iodized salt. So this salt says this salt does not supply iodine. That's what it says on here. So if the salt says iodine, you cannot use it. But if the salt says this does not supply iodine, and if you look on the back on the ingredients and you do not find iodine or any variations of that name with iodine in it, then you know that you can use normal table salt. So I bought this from the store. For this experiment, you will also need a small amount of food coloring. I have kind of rigged up a syringe here, one of these medication syringes you might get for your children when they're sick, and I have attached an ordinary drinking straw to it. This is what we will use to suck out the alcohol. And then, of course, I need my bottle of rubbing alcohol. And I also need a clear container. Now, we tried to use several different containers. First of all, we tried to use a purified water container. Some of the problems we found was the purified water containers are not smooth on the outside, and they have all of these little ridges and bumps and geometric shapes, which really help make the plastic a whole lot stronger, but it doesn't work for us in our case where we need to see something clear. So in this case, what we used is we used an ice bottle. There's a drink called Ice, I-C-E, and they have nice tall clear bottles, and we removed the wrapper from this bottle. So we're going to use that for the case of our experiment. So with that, we'll now begin our experiment. Okay, so we're going to get started. I've chosen a small paper plate to put things on. I think it just makes things a lot cleaner because you'll see after a while there is a transfer process that's going to require, not dropping things on a table in case you're worried about preserving your table, especially the fact that we are using a bit of food coloring today. And that may make things die a little bit if we're not really careful. And that's D-Y-E, as in die, not D-I-E. So anyway, okay, so the first thing I'm going to do is I'm going to pour myself about half a cup of salt. And again, you can use the ice bottle as reference. Many people now drink the ice drink, the ICE drink. It's very popular, it's sugar-free, and it's very good for you. So we're going to put about half a cup of salt here, and we're going to go ahead and put that in this 1 cup container of salt. And now I'm going to begin pouring this salt in the large ice bottle. And so you notice again, this helps a little bit control with the spillover of the salt. Now, really, you could use a lot of salt. It's not exactly scientific. I'm just trying to give you some rule of thumb guidelines as we go along so that, whoops, there we are. All right. Stills a little bit in. All right, I'm just going to clean up this bit mess right here. Okay, so you can now see that the container contains a large portion of salt at the bottom of the container right here. Now what we're going to do into that container is we're going to take some alcohol. I've already removed the safety tab from the top of the alcohol. And so what I'm going to do here is I'm simply just going to pour the alcohol into the salt. No mystery explosions here, so we're just going to pour the alcohol right into the salt. And so we're just pouring here until all the alcohol from the jar gets into the salt. Alright, so now we've completed pouring all the alcohol. Now go ahead and save this alcohol bottle, because one nice thing we can do with it is after we purify our alcohol, then what the goal is today, so let's just go over that quickly before we start this process. This is 50% alcohol, 50% water, 50% alcohol. We now need to get close to the alcohol as pure alcohol as possible, but we can only get to about 99 and some percent. It's called the isotope of alcohol. We really can't go much past that, but you know what the CDC says, in order for it to be effective against the coronavirus, we only need to have about 70% purity. So you can see we have quite a bit from 90 to 70, and we can handle that quite nicely. There's a big cushion in there. So we're trying to achieve about 99% alcohol. So the next step in this process is, so that we can aid in seeing this process a bit better, we're going to add a drop of food coloring. So we're going to go ahead, we're going to add a drop of food coloring in here. And the food coloring, you say, well, why do we need to add a drop of food coloring? Well, there's a process in here that goes on where we are actually going to need to use the syringe to actually separate the alcohol from the water. And the food coloring makes it a whole lot easier for us to do that. So now with this, we're going to take a cap, and we're going to put the cap on the top of the ice bottle, and then we're going to shake vigorously. So we're going to shake, and this may take us a couple of times. Hopefully we have enough salt. I believe that in our earlier experiments, this was around the amount of salt that helped separate. So we're going to shake it up vigorously. Okay, it's been on about a minute now since we've shaken the bottle, and as you can see here, we're seeing with the food coloring where we are developing a clear separation between the salt water, which is being separated to the bottom, and the pure alcohol, which has been lifted to the top. Now how this works is the salt and the water mixed together, they formed a solution, and that solution is heavier than the alcohol. So therefore that solution sinks to the bottom, and the alcohol solution sinks to the top. So now we're in a situation where all we have to do next is suck the alcohol out of the top, and that does require kind of a two-person operation to be efficient. So I'm going to cut here and then show you together with my son how we go ahead and make that extraction. Okay, now we're going to do an extraction process. We've found that this is easier if you have a second person. However, you can do this yourself. But what you would see, as you saw before, is there's a separation between the alcohol and the water. Alright, so we're going to go ahead and now try to do some extraction. So I'm going to give the extraction tool to my son here. I'm going to take off the top of this, and then I'm going to provide a bit of light because we found that's very helpful in seeing the level. And we can move that over here. And actually, let's move that onto here, right beside it. Right here, because now we find that we can control a bit of that. All right. So one person can kind of shine the light. And we are going to start beginning to extract the alcohol. Now, what you'll see is you'll see a level down here. The level in this case is right about here, where there's a separation between the alcohol, which is on top, and the salt water, which is on the bottom. I've seen this done with different dyes and food coloring. It looks like purple tends to work very well. Blue and green just kind of give a light blue and a lighter blue for the alcohol and a darker blue for the salt water. But I think purple food coloring tends to work well and provides a bigger contrast. What we're doing here is we're taking this straw contraption that we've created, hooked up to a medicine syringe, the kind you would just find at Rite Aid, or that you would have with your child's medication if you have oral medication in a small child, such as some sort of antibiotics that they give children orally. And then we connected an ordinary drinking straw to it because we didn't have any fish tank tubing, which would have been the best to connect to, but this works for us. So we're just going down here now and we're extracting all of the alcohol out of the process. So out of our solution, excuse me, here. So you have the solution and we're just extracting. So we want to make sure that we don't put the straw in too deep. And therefore we're just going down to the level where we see that salt water separating from the alcohol. We're putting it on top of that, and then we're sucking it and we're placing it inside. Alrighty. Well, we'll go ahead and finish this up and then show you guys what it looks like in the end. Okay, so now we've used our extraction tool here, and by extracting out and transferring to this bottle, we've gone ahead and transferred that entire top layer of alcohol. And so now what you see, minus the salt, there's quite a bit of salt at the bottom here that we started out with. What we came out with was really about 50% water and 50% alcohol. If you removed all the salt that's sitting at the bottom of this, these two levels would be nearly identical. And also the volume of the containers is a little bit different. But really we do have a 50% water over here. It's a salty water, very salt water. And then we have about 99.9% alcohol here. So we successfully converted rubbing alcohol, ordinary rubbing alcohol, into a very high proof 99.9% alcohol. Now there's a couple of things to really note at this point also, just to talk about. Some people have believed that when making alcohol, hand sanitizer and things, they can just go ahead and down to the liquor store and get some vodka or some whiskey or some really, really high proof liquor and then mix that and make their own hand sanitizer. The problem is the coronavirus is not necessarily killed by a 50% weak alcohol mixture. And by law, you cannot drink 99.9% alcohol, because if you did, you would get alcohol poisoning and get very, very sick. So when you talk about 100 proof, it's not really 100 proof. It's really about half of that. And that's what the government requires so that people don't get alcohol poisoning. So the alcohol we're trying to create today is very, very pure. Now, having said that, please do not drink this alcohol. First of all, it's isopropyl alcohol, which is made, which is not intended for drinking whatsoever, and it's also far too pure. It may contain impurities, things like that. So you do not want to drink this alcohol. Do not attempt to drink this alcohol. You will get alcohol poisoning if you try to drink such pure and straight alcohol as this. This alcohol is designed for the demonstration today to be used in hand sanitizer. We are trying to create hand sanitizer due to the current coronavirus situation where there's not enough hand sanitizer. We are trying to create some and show people if you really need hand sanitizer and there's none around, as there is right now here in Southern California where we are, there is no hand sanitizer. It is completely sold off all of the shelves. This is the purpose of this. So with that, now we're ready to move on to our next step. Okay, so now we have created our condensed alcohol. We condensed 50% rubbing alcohol into around 99% alcohol. And the alcohol is still isopropyl alcohol, but it's at a much greater concentration. So with this, we're going to work on a formula to create some hand sanitizer. So the things that we have here is we have some aloe vera gel, we have our rubbing alcohol, we have a couple of measuring cups and a spatula for mixing up the mixture and a small mixing bowl. So what we're going to do here, I didn't exactly have a 2/3 cup, so we came up with an interesting idea. My son came up with an interesting idea. We're going to use another method for creating that. All right, so what we're going to start off with is I'm going to move some alcohol here. We'll start with this one first. I'm going to start off with 2/3 cup of alcohol because the mixture is going to be 2/3 alcohol to 1/3 aloe vera gel. So here I'm just simply going to pour one of our condensed alcohol and get complete 1/3 cup of this. Pour this in my bowl. Another 1/3 cup. And pour that in the bowl. So now that's 2 1/3. Since we didn't have a 2/3 cup, that's what we're going to do. So we now have 2/3 alcohol in the mixing bowl, and now we're going to go ahead and we're going to squeeze out 1/3 cup of aloe vera gel. So we're going to squeeze that out. There we are. Go ahead and squeeze that out into this cup and level it off and make sure it's 1/3 cup, which it is. Now we're going to pour that in the mixture like that. So now all that's left to do, little messy there. We're going ahead and just mix this until we get a nice consistency, and it is mixing slowly. We're getting pretty good consistency here. Got to be careful I don't get too vigorous, make any more spills. So I'm mixing. And we'll be back in a minute once it's been mixed.